Howdy, 8th grade. Today we are going to be looking at similar shapes and proportions. And I want to show y'all proportions. How we can use proportions and ratios to actually work in geometry. So before we get started on that, what similar means? It means the same shape but a different size. So when you think similar, you can think of a little square is similar to a big square because they're the same shape but a different size. Something really cool about similar shapes is that they'll have a scale ratio or a scale factor. So a scale factor is going to be the ratio of the sides of one shape to the sides of another. So what that means, it sounds kind of silly, but it's going to actually be very, very useful. If I have a triangle here, and let's say this triangle has side lengths of 3, 4, and 5, and I say that is similar to a big triangle with side length 8 and 6, and I don't know what this is. What this tells me is that the ratio between 4 and 8, so my ratio of 4 to 8 has to be equal to my ratio of 3 to 6, which has to be equal to my ratio of 5 to whatever this number is. And I'm going to put a question mark there. If I look at this for a second, it should be pretty obvious that the number on the bottom, 4/8 is a half, 3/6 is a half, 5 over what's a half? That would be 10. So just like that, I could figure out that this number here should be a 10. Something else I wanted to tell y'all is, let's say that there's a scale factor of a over b. So up here we had 4/8 as our scale factor. We're going to say that we're just generalizing it. We have some scale factor. Let's call it a over b. The perimeter of the new shape is a over b times as big. The area is going to be a squared over b squared times as big. And the volume is a cubed over b cubed times. So what that means is if I have, let's say a cube, I'm going to do that in a different color. My example here is I have a cube with side length 4, and let's say I have another cube 3/2 as big. Well, if I have a cube with side length 4, that means that the volume is going to equal 4 times 4 times 4, which is 64. My other cube, which is 3/2 as big, 3/2 of 4 is 6, so my new volume would be 6 times 6 times 6, which is going to be whatever 36 times 6 is. That's 36 and 180, 216. But this right here is telling me there's a different way I could go about that. So it should be a cubed over b cubed times as big. So I should be able to take 64 and multiply it by 3/2 cubed. Or I could do 3 cubed over 2 cubed, how that's written. So I know 2 cubed is 8, and 3 cubed is 27, so that'd be 64 times 27 over 8. And when I solve this, I would get that it is 8 times 27, which is going to be 216. So if you wanted to use the ratios, you could, or you could just plug it in the long way. Either way, you'll get that it works. So if I can get y'all to please do the lesson practice, it just goes through E today, A through E. That would be delightful, and I'll see you in class tomorrow. Toodaloo.